Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 10, Lesson 7, Linear Regression on Calculator. So, in the last couple lessons, you've worked on graphing a scatter plot, talking about bivariate data. Now what we're going to do is write and draw the equation of a line of best fit. Once we have the equation of line of best fit there, we're going to use the linear regression. We will work on the first exercise with you. By entering the data. A couple things when we go back to our graphing calculator. Don't forget we have to identify my A column as X and identify my B column as Y. The next important thing to make sure that you match your numbers up correctly going down in each column. Once you have both in each column, you're going to hit Control plus Page or Control Doc, and you want to insert a new data or statistics graph. Once we have the new data and statistics graph, your data is going to be plotted onto your graph in just a random area wherever your points are. The reason why they're random like this is because your axes are not identified. So your points are just there because those are values. Your next slide, your last slide on this page, in order to create a scatter plot, you just have to go ahead and insert for your X column, you have to insert X, and then insert your Y column, and then your data automatically gets organized to be a scatter plot. The nice thing about these new calculators is that you do not have to adjust the window like it suggests in your packet. All you have to do is go ahead and follow these simple directions, and a scatter plot will be created. As you can see, the scatter plot is a very nice scatter plot. It shows you that it has a positive correlation because your dots are traveling in an upward fashion, and it has a positive slope. The other thing that you need to notice in Lesson 10.8, we're going to talk about how close your dots are together. We mentioned it in class a little bit that the closer the dots are together, the better your line or more accurate your line of fit will be. Question B says, use your calculator to find the equation of the line of best fit. Round the slope in the line to the nearest hundredth and the y-intercept to the nearest integer. Compare this to the slope you found in the last lesson. So in order to go ahead and write the line of best fit, whenever we want to do anything to a window in our calculator, you always want to hit menu. Once you get to menu, you want to say, okay, what are we going to do? Well, we're going to analyze our graph. So let's hit 4, Analyze. And you can see it down in this window right here. So I hit 4, Analyze. And then we want to take care of a regression. Well, they are saying that this is an equation for the best fit of line or a linear function. So we want to use linear. If you look at this long list here, you can show the exponential regression if they think it's exponential, or the quadratic, or the cubic. So make sure you choose the right one. Read the directions carefully. We're going to show the linear regression. What it does is it draws a line of best fit through your graph, and in your graph you can identify what your linear regression is. Don't forget that you can click onto that data on your calculator and move it out of the way if you can't read it. But the information that it has here, it says write the equation of line of best fit, and it says round your slope to the nearest hundredth. So I'm going to say that my slope is 1.16, and I hope I can read that through on my screen. So my slope is going to be, it's going to be y equals 1.16 x. And my y-intercept to the roundest to the nearest integer would be 19, plus 19. So once again, my answer is y equals 1.16 x plus 19, and that is right here. That is my equation of the line of best fit. Just explain what the y-intercept in this model represents in terms of the low and high temperatures that are being modeled in this problem. It says, so the y-intercept is at beginning. If we go back to the first page and it says my low temperatures to my high temperatures, it says that my low temperature, if my low temperature is 0, that my high temperature would be 19 according to this graph. So that's what my y-intercept is stating, that if my low temperature is 0 degrees, my high temperature is going to be 19 degrees. How would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? Well, according to your slope, that for every 1 degree that it changes, it's going to go up 1.16 degrees in the other direction. So my slope is going to be 1.16. So that's how it's increasing over 1 degree for each change. If you have any questions, make sure that you stop in and see us after school, and don't forget we will be starting to study for final exams.